Okay, now for the second lesson on solving radical equations. Same idea, same process, but some of these problems will have to isolate the radical more than once. So just begin. I want to isolate the radical, so I'm going to subtract by x on both sides. And when I square both sides, I have to remember to square everything on both sides. And keep in mind that 6 minus x squared is equivalent to 6 minus x times 6 minus x. So what you get here is 36 minus 12x plus x squared equals x. This is now a quadratic equation, so I have to move everything to one side and try factoring. So you get x squared minus 13x plus 36 equals 0. Two numbers that multiply to 36 but add to negative 13 are negative 9 and 4. The two solutions you get are 9 and 4, but when we check them back with the original, only one works. So 6 plus 9, 6, does that equal 9 plus the square root of 9? No, because 6 does not equal 9 plus 3. So that's definitely not a solution. For the other one, does 6 equal 4 plus the square root of 4? Yes, because 6 equals 4 plus 2. So that works. So the only solution here is 4. Now for the rest of the problems in this section, I'll probably just tell you which one works out and which one is extraneous, and you can check on your own. Okay, number 1. Same idea. Isolate the radical. Subtract by 1 on both sides. At this point, you could divide both sides by 2, but it's definitely going to make your life a little bit harder because now you have fractions. So I actually recommend at this point leaving it and squaring it. So when you do 3x minus 1 squared, that's 3x minus 1 times 3x minus 1. When you do 2 root x squared, that's 2 root x times 2 root x. Multiplying out the left side, you get 9x squared minus 6x plus 1. Multiplying out the left side, you get 4x, because you can rearrange this to be 2 times 2 and root x times root x, which is 4, times root x squared, which is just 4x. Okay. Again, it's a quadratic, so move everything to one side and factor. I'm going to factor using guess and check. So I know that this number comes from the product of whatever the first two terms are. So I could do 3x and 3x, or I could do 9x and x, 1x. I'm going to stick with 9x and x because that number is pretty big, so I feel like I'm going to need a bigger number. Then I need two numbers that multiply to 1. Well, it's just 1 and 1. And because this middle term is negative, I'm going to guess that both of these are negative, because negative 1 times negative 1 does give me positive 1. So I just made my guess. Now let's check it. If we FOIL, we get 9x squared. Outer, we get negative 9x. Inner, negative 1x. Last, positive 1. Combine like terms, and we get negative 10x. So this is correct. Okay. Set each piece equal to 0. And you get x equals 1/9 and x equals 1. 1/9 ends up being extraneous, so the only solution is 1. Now I do want to show you how we could have done this problem this way. So at this point, I would square both sides, and that means in the numerator, I have 3x minus 1 over 2, 3x minus 1 over 2, and x. Okay, I already did 3x minus 1 times 3x minus 1. We know that's 9x squared minus 6x plus 1 over 2 times 2 is 4, so 4x. Times 4. To solve for x, I would multiply on both sides by 4. So notice I get the same thing that I did here with just less steps. Okay, so it still works, but it's just a longer way of doing the problem. I think this way is definitely easier and more efficient. All right, moving on. 2, again, isolate the radical, so I'm going to add by x on both sides. Now I'm going to square both sides. So that's going to be 9. Actually, I'm going to put it in standard form. X squared plus 6x plus 9. 4 squared is 16. Root x squared is just x. Move everything to one side so I can factor. Two numbers that multiply to 9 but add to negative 10 are negative 9 and 1. So I get 9 and positive 1. And both of them actually work in this case. So both are solutions to the equation. Okay, next one. I already have the radical isolated, so I'm just going to immediately square both sides. Move everything to one side. And factor. So the two solutions are positive 4 and negative 1, but the negative 1 is extraneous, so only 4 is the solution. Here, it's not possible to isolate both radicals at the same time, so I'm just going to isolate one. And it doesn't matter which one you choose. Now at this point I could technically stop because, remember, the square root will always be a positive number. So I'm saying a positive number equals negative 2 times, again, that would produce a positive number. On the right here we have a negative times a positive, which is going to produce a negative. So we're saying a positive number will equal a negative number. That doesn't make sense. So at this point you could stop and say there's no solution. Ooh. But let's say you didn't realize that. You could keep going, square both sides. Distribute. And when you check this with the original equation, it's just going to give you a false statement. So let's see. 39 times 3. Probably would have been easier to just do it in my head, but 117. So 117 plus 7, that's going to give me 124. And then 39 minus 8 is 1. Square root of 124. Did I do that right? 3 times 39 plus 7. Let's double check. Yep, that's what it's saying. Well, regardless, square root of 1 is 1. 2 times 1 is 2. 2 plus that value could still never equal 0. So, no solution here. Okay. Similar to number 4, in example 2, it's impossible for me to isolate both radicals at the same time. So I'm just going to pick one. I always like to deal with the more complicated part, so I'm going to isolate the root x plus 3 first, take care of the more problematic radical, and subtract by root x on both sides. Now I'm going to square both sides so that I can get rid of one radical. That gives me x plus 3. And then on the right, I have 3 minus root x times 3 minus root x. So when I FOIL that, I'm going to get 9 minus 6 root x plus x. Now, outer, just to show you that work, when I do outer, I have 3 times negative x, which is negative 3x. Inner, negative x times 3 is also negative 3x. So combining like terms is what gives me the negative 6x. And then last, I have negative root x times negative root x. Negative times a negative is a positive. Root x times root x is root x squared, which is just x. Then I need to combine what I can combine and isolate this radical. So if you subtract by x on both sides, those are gone. If I subtract by 9 on both sides, you get negative 6 equals negative 6 root x. Divide by negative 6 on both sides and you get 1. Square both sides and you get 1. And when you plug 1 in, do you get 3? 1 plus 3, 4, 2. So it checks out. So 1 is the solution. Okay. Last two. Same idea. It's impossible to isolate both, so just isolate one. They both look the same more or less, so I'm just going to isolate x plus 5. So that means 4 minus root x minus 3. Square both sides. That leaves you with x plus 5 equals, here you're doing 4 minus x minus 3 times 4 minus x minus 3. Oh, forgot the 4. And foiling this, I'm going to treat this like the last term in each parentheses. So first, 4 times 4 gives us 16. Outer, so I'm doing 4 and negative root x minus 3, so that's negative 4 root x minus 3. Inner, 4 times negative root x minus 3, so that's going to be negative 4 root x minus 3. And then last, I have negative root x minus 3 times negative root x minus 3. So negative times a negative is a positive, and root x minus 3 times root x minus 3 is root x minus 3 squared, which is just x minus 3. Combining my like terms, combining negative 3 and 16, I get that. And then bring down the x minus 5. So now I want to isolate this radical. So subtracting an x by both sides, these cancel. Subtracting by 13 on both sides, I get negative 8. Divide by negative 8 on both sides, and you get 1. Square both sides. Add 3, and you get 4. So 4 is the final answer because when I plug it back into the original, it does work out. Okay, last one. Here I already have one radical isolated, so I'm just going to square both sides. So on the left, I have that. On the right, I have this. So you get 9 plus 6 root x plus x. Combine your like terms. Divide by 6. Square both sides. You get 144, and that will work when you plug it back in. And that's the end of that lesson.